All right, so there was a question about this particular problem where you're given two charges in the xy plane, and then you have to find the electric field that they create at the origin. So this is sort of the scenario. I have charge 1, my Q1 is minus 4 nanocoulombs, which is minus 4 times 10 to the minus 9 coulombs. It's at the point x equals 0.6, y equals 0.8, so I'm going to kind of be a little rough here. I'm going to say that this is 0.6, 0.8. This would be the coordinates, and this is where Q1 is. Q2, my Q2 is 6 nanocoulombs, which is 6 times 10 to the minus 9 coulombs. It's at the point x equals 0.6, y equals 0. So it has the same x value, but it's on the x-axis. Now we want to find the electric field that they create here. So I'm going to draw, remember that we draw the electric field as it's at a different location but is being created by a particular charge. So for Q1 is a negative charge. So the electric field it creates will go in towards it. So I'm going to draw the electric field it creates, and I'm going to label this E1 because it goes towards Q1 along the line between the origin where we want to know the electric field and where the charge is found. Q2 is positive, so it creates an electric field away from it. So at the origin, it would be pointed in this direction, and I'm going to call that E2. So I use the sign of the charge to draw the direction of the fields. Now I have to add them like vectors. When I'm doing that, I'm going to be, taking into account my picture and use that to know if it has positive x or y coordinates. I use the expression for the strength of the electric field, that E equals kq over r squared. I want to find the strength of E1 and E2. So E1 would be 9 times 10 to the 9th. Q is 4 times 10 to the minus 9. And if I find the distance here is, for R1, is from here to here. And if I do the Pythagorean theorem, that actually turns out to be 1. So that's easy, 1 squared. Notice I didn't use the sign of the charge in this calculation, and the reason for that is because I already used the sign of the charge to determine the direction of the electric field. Now I just want to know its magnitude. And the magnitude that I got is 36 newtons per coulomb. I'm going to do the same thing over here for E2. It's 9 times 10 to the 9th, 6 times 10 to the minus 9. The distance here is just the distance between the origin and Q2. That one is just 0.6. And so this answer, I get 150 newtons per coulomb. All right, so I'm going to go to the next slide just so I have a little bit more room. And I shouldn't have, just to remind you, this was E1, look like this. E2 look like this. This had a magnitude of 36 newtons per coulomb. This was 150 newtons per coulomb. I also need to know this angle. The angle, because of the coordinates, remember the coordinates for this point for where Q1 is, was 0.6, 0.8. So the tangent of theta was 0.8 over 0.6, and so theta turned out to be 53.1 degrees. So I did need to find that. Now I'm going to add my vectors, adding their x and y components for the total x component. So that's E1 plus E2 is E total. I have E1 times the cosine of 53.1 degrees minus E2. E1 has a positive x component, E2 is all in the negative x direction. So I get 36 cosine of 53.1 minus 150, and I get minus 128.4 newtons per coulomb. For the y direction, I just have E1 times the sine, 53.1 degrees. E2 was only in the x direction, so it doesn't contribute it. This is 28.8 newtons per coulomb. The total I find by using the Pythagorean theorem with these two components, the x and the y component that I just found. And I find the total value is 132 newtons per coulomb, so that's the strength of my electric field. In order to find the direction, I find the tangent would be given by the y value over the x value. I do have to put in the sign here, so I get 28.8 over minus 128.4. My angle I get is minus 12.6. Now, this is a reference angle, because when you did your calculator, it didn't know if your x or y value was negative. Using my components that I found from adding the vectors together, this has a negative x component and a positive y component, and I know that E total is in the second quadrant. So phi is equal to minus 12.6 plus 180, and that's how I get 167 degrees. And that's my angle phi. Hopefully this helps. But this is an important skill to know, how to add electric fields together due to different charges. And it reviews some of the things you learned about adding vectors from last semester.